What's up, guys? So, let's talk a little bit about subwoofers and how they can die. So, there's been a lot of emphasis placed on clipping, signal clipping being bad for subwoofers, for speakers in general. Well, the first thing you have to understand is that clipping a signal does nothing to a speaker. Nothing at all. Guitar amplifiers, other musical instrument amplifiers for years have been playing a clipped signal, which is how distorted guitar or rock and roll guitar, that's how that sound is created. They take the sound wave, right, of a normal guitar, and then they clip it. There's a gain knob and a volume knob, and the gain cranks up the preamp signal until it clips, and the amount of gain you give it determines how much clipping it's going to get, which determines how saturated and distorted that signal gets. But the fact is, the speaker is reproducing that sound, and it's extremely distorted, extremely clipping. But it doesn't hurt the speaker. It doesn't hurt any speaker. A speaker is merely the end of a chain of things. It's a motor. That's literally all it is. All it is a motor. Clipping a signal to a speaker is no different than squeezing and releasing a trigger on a drill. It's not going to make it burn up. Now, what will cause a driver to fail, as far as I know, there's basically two ways a speaker of any kind can fail. One is mechanically, and that can be the wire coming loose from the voice coil or from the tab, or it could be the spider becoming disconnected from the basket. It could be the cone becoming disconnected from the surround, or the surround being destroyed, or anything. Any of that stuff can cause a mechanical failure. And then there's electrical failure, which is still kind of a mechanical failure, but it's more directly related to the electrical nature of the motor. Okay, and that is when the coil itself gets too hot, and the coating on that coil, the coating on that individual wire, melts, causing two wires to contact each other and create a short in the coil. Or it could literally burn in two. The wire could get hot enough to burn in two. But those two things, that short and that burning in two, those are both created by heat. Heat and over excursion are the two primary ways you can kill a speaker. And clipping does neither one of those things. Electrical clipping, signal clipping, okay? On the other hand, there are two types of clipping. There's the signal itself clipping. Even at low volumes, it's still going to create that clip sound. That won't hurt anything, at least not in the speaker world. The second type of clipping is mechanical clipping. That's where the driver, in trying to go up and down and ride that wave, has reached its maximum amount of excursion and is now hitting the end of its travel, and it can't create that hump. It can't go up and create that hump, so it just goes bam and straight across and comes back down. That kind of clipping will absolutely destroy a speaker. That's going to cause stress on the least tolerant area, which is usually the spider. It'll rip the spider apart because the spider is getting maxed out on both ends. It's designed to move up and down and control the linear movement of the motor, But if it's getting pushed past its mechanical limit, it's hitting both ends hitting. That also means that the speaker is going up and staying put, and then coming back down and staying put. So there's the impact of it going up and hitting the end of its limitation. Also, there is the fact that it's getting pushed and held into a position each time. Those two things will create mechanical stress and heat in that voice coil. Another thing that creates heat in the voice coil is just too much power. If a driver can handle, whenever they give their rating on the driver's power handling, that is within a set of parameters. So it's 500 watts RMS, quotes and asterisks, right? The asterisk is, within this frequency range, playing this type of information, all of these things are considered. For the most part, there's a bit of standardization that's going on in the driver world, where we assume a subwoofer is going to be playing 20 hertz to, say, 100 hertz. And that's what it's rated for. So if you're saying it'll handle 500 watts in an enclosure designed for the air cushion that driver needs, and we're playing between 20 and 100 hertz, musical information, which is not a constant sine wave. All those things considered. They go without saying, they're not listed, but these are all things. Now, what if you take that same driver and put 500 watts on it, or whatever I said, with no enclosure, and you play 10 hertz constantly? Is it going to destroy itself? Yes. On the same note, if you took that same driver and put 1,000 watts on it, where it's playing, mostly high bass and stuff like that, in a sealed enclosure where it's getting a lot of air cushion, and you're only doing it for a few seconds at a time, you could do that all day. Again, the situation the speaker is in will change, the characteristics will change how much power handling it has. So just because it says it's rated at 500 watts RMS doesn't mean you can do anything you want at 500 watts RMS and it'll just take it. On the same note, you can put 2,000 watts on it. You can put 5,000 watts on it under the right circumstances. So that watt rating isn't a be-all, end-all, okay? But having said that, putting too much power on a coil, because a coil is essentially a short. If you look at the way it works is, you're coming off of this terminal, going around and around and around and around and around and around, and then coming back to this terminal. So it's not a dead short, but it's only got a tiny bit of resistance. I mean, it's literally one wire that goes through a system, comes back down. It's a short, okay? And what happens when you connect one wire to one battery terminal and one wire to another battery terminal, that wire will get really hot really quick and just melt and burn. Well, that's what your voice coil on your speaker is also experiencing. It's literally like taking a cord and plugging one half of it into a light socket and the other half into the other light socket, and watch what happens to the wire. That's a 60 hertz, 110 volt note. If you plug a subwoofer into a light socket, it will play 60 hertz loud for a few seconds, or maybe 10 minutes, depending on how tough the thing is. The point is, that coil has to absorb all that heat. Okay, it's getting hot, and because of the nature of what it does, carrying power from point A to point B, it's going to get hot. Now, how well it cools is going to depend on a lot of factors. But for example, the material of the voice coil, the material of the wire itself. Aluminum actually cools a little better than copper does. But copper actually conducts heat a little better than aluminum does. Don't quote me on that, but I'm pretty sure that's the case. So aluminum likes to give up heat to air faster, and copper will conduct heat from point A to point B better. But they can both be used interchangeably, which is, and in a speaker's case, any kind of speaker, they usually use a copper-clad aluminum coil because of its weight savings. You don't want the mass of that copper coil, back and forth. Or maybe you do. It just depends on the design parameters for the driver. But the design of the coil itself, the material, how many layers it has. If it's multiple layers, it's going to soak heat more than if it's one layer, right? The type of resin and glue is going to dictate how well it can handle high heat, but also going to dictate how well it dissipates heat. So you're gonna have a thicker wire with a lot thicker glue and all that. That's going to hold heat more, but it's also going to handle high heat better. So then you got the movement of the driver. So as the driver's moving, that moves a lot of air over that coil. Do you have a system in place to help direct the flow of that air across the coil itself? Or is it just creating turbulence? A lot of companies put a lot of research and development effort into making a speaker effectively use that air it's moving to pull across that coil each time and keep it cool. There's so many elements involved, but ultimately heat, badly designed driver, a badly designed motor, bad cooling, the wrong coil, or the person just putting too much power under the wrong circumstances on that driver. These are the things that kill voice coils, with the heat. Not clipping. The signal, it doesn't care. It doesn't care what signal is coming to it. It is there to reproduce the signal, whatever it is, and it's going to do that. Mechanical failures can be from a lot of things. Most likely, it's going to be from a couple of things. Way too much power on a subwoofer that's in a sealed enclosure, and just that the cone can't handle the force of compressing that air, and so it ruptures in some sort of way. That's not the most common failure, though. Most common one, I think, is going to be broken tinsel leads, and ripped off spiders that have become disconnected from the basket. Because the spider, being the most limiting of all the components, it's the one that takes the hit whenever you're mechanically clipping that driver. You're trying to create a sine wave that it just isn't. The driver can move this much, the sine wave is this big, it's just going to go up and hit, and then come back down and hit, and go up and hit. It can't move enough to faithfully reproduce that wave. And that will destroy a speaker. That also will cause heat, which goes back to the first one again, because it's impacting and holding, and then releasing and impacting and holding, which means it's trying to move, but it can't. So all of those elements can work together to destroy the driver. Anyway, the point of all of this is, don't be stupid. Treat your stuff like it matters, and don't expect the manufacturer to warranty stupid. They warranty the product if it's used as they recommend. If it's used in some ridiculous way, they can't really warranty that, and they're not going to. And I don't blame them, because stupid. But as far as clipping goes, electrical clipping, a clip signal sounds bad, but it doesn't hurt anything. There are plenty of other YouTubers out there that have tested this theory. So, dig deep. Don't stop on the surface, because you'll find a whole lot of naysayers. But dig deeper, and you'll find people that have actually tested it, and they know that it's just a dumb concept. Anyway, guys, I hope you found this interesting. If you did, be sure, there's a fly in my ear. Be sure and hit the subscribe button down below. And by far, the most important thing is to get into the comments and tell me how wrong I am and why I'm wrong, and how, all that stuff. Get the torches and the pitchforks. Let's get her going. Peace, guys.